Welcome everybody. My name is Ryan Schul. Welcome to my data science channel. So in the project today, I want to talk about analyzing traffic patterns for a large city. This can be very, very, very useful because it can help city planners organize, strategize, coordinate transportation agencies, businesses, and even hopefully, definitely citizens can make smarter decisions and not get caught up in traffic and not be like in this congestion nightmare. Personally, I hate traffic. Sometimes my wife gets angry because I get angry at the traffic and like all these people are like honking their horns. The light turns green, but and instantaneously, and the horn is honking as soon as the light turns green. Doesn't make a lot of sense, right? Like a lot of people don't like traffic. Maybe there's someone out there that actually enjoys traffic. I've never met anyone in my life. So let's forget that and try to optimize the scenario and try to make things more efficient, right? So how can we do this? We can reduce congestion, improve public transit, emergency response and safety, urban planning, and controlling the entire infrastructure of the city. Obviously, there's an environmental impact. I'm a huge environmentalist. Like I love recycling. I love reduce, reuse, recycle types of things. There's an economic efficiency perspective as well, right? Like obviously, like if the traffic just flows, it's better for the economy. And there we can do real-time predictive applications and real-time predictive analytics as well. This video is not necessarily tailored to that, but that's one outcome from this type of analysis, right? So I'm going to go ahead and import the data. I have this data set right here, Control Enter to refresh the cell. Okay, and we're going to look at the different traffic patterns and order the traffic in specific like human logical order, because it doesn't come to us like that. Like I have to go ahead and assign order or some type of logic to the time series right here, right? So obviously like 12 o'clock to 1 a.m. is early in the morning, 1 a.m. to 2 a.m., 2 to 3, 3 to 4, and then so on and so forth. Then we have 7, 8, 9, 10, 11, 12 p.m. So this is the order that we're going to analyze the data set that we have, because it doesn't come to us like this, right? So we have to create a feature. This is called feature engineering. If you've seen my other videos, this is feature engineering. We're creating features where we can tell the data what we need. We can give it commands, we can give it instructions, and then derive a more efficient hypothesis or a better guess from what the data is telling us. So I'm going to go ahead and import the data and arrange it in a logical order. Like this is a human order, right? So 12 to 1, then we have 7, 8, 9, 10, 11, 12 p.m. This is how the clock works. But the data doesn't come to us like that necessarily. If it does, that's great. If it doesn't, we have to remanufacture it and like control the data and manage the data to do what we need it to do. Okay, so I'm going to go ahead and create a heat map over here. Okay, and you can see right here it's pretty obvious. Like larger is darker, bigger numbers are darker. Over 600, almost to 700 is darker, and lighter is like light yellow, right? So we have dark orange or dark red right here, and then lighter is less. So this pretty much aligns with traffic patterns. So if you look right here, 6 a.m. to 7 a.m., things are getting busy, like it's picking up. 7 to 8, 8 to 9, 9 to 10, like things are getting going, and then there's definitely flow over here. This is like overnight, right? Like most people are sleeping. There's some people at work, third shift, and there's movement, there's activities, and there's interactions, right? And we have traffic flow, but it's much less over here. 2, 3, 4, 5 a.m. picks up here. 6, 7, 8, 9 a.m. kind of like drops a little bit, right? We have a little dip over here, but then at the end of the day, we have a second rush hour, right? So we have the morning rush hour and we have the evening rush hour. So we have two, and you can see over here it's building up, okay? And over here it's building up a lot, right? And then again, it drops off, and then we get into 10 to 11 p.m. and 11 to 12 p.m. and traffic is dipping down, right? So this is the number of cars going through an intersection in several different areas in New York City, right? So we captured all the data for New York City, all the traffic patterns, and what's going on in this region, right? I live in New York City, so I tend to do most of my analysis on New York City, with a few exceptions. I did some on Boulder, Colorado. I'd like to move to Boulder. It's very beautiful. It's very like environmentally friendly and these types of things. Like I would like to go there sometime soon. Hopefully that will happen, but I don't know. I don't have a lot of control. I feel like life is kind of random and you have to level up and do what you have to do. So right now I'm in New York, so I do a lot of analysis in New York, but eventually I would love to go to Colorado. So we can change the locations and make all of these unique and get an actual address from and to, because with the data set, if I open this up, this is sitting on my desktop right now. Like this is called traffic volume count. So if I go to my desktop, traffic volume counts, where is this thing? Oh yeah, here, over here, okay. So I have a picture of an eclipse right here. This is the eclipse that went through New York City. It was like, I think 90% eclipse, which is kind of interesting, but not like really dark. It doesn't get really dark because we're not in the middle of it. But I like these types of eclipse things. Okay, so here's the data, right? So we have the from and the to. Here's the from and the to data, and I'll show you where to find this at the end of the video. So we're going from Union Place to Van Duzer Street. I'm not even sure what the heck that is, but we have the dates, and then we have the counts of the vehicles going through that congestion area or that intersection, right? So we have the counts of the cars. So that's what we're looking at here. So to flip back to that scenario, that analysis, yes. So we have the heat map here. Yeah. So you can see obviously like overnight, not too busy, rush hour, busier, middle of the day, kind of like drops down a little bit. We go to a valley, then it peaks up again. And then we have the kind of like tapering off the valley again, right? So we have here the from and the to, and we're getting the full address here, okay? So we get the full address based on this Union Place and Van Duzer Street of New York. So I'm concatenating together a couple different data frames, or a couple different parts of one data frame into one to create a from and a to get the full address. Where are we going from and where are we going to? This is kind of like an Uber. Okay, I'm going to pick you up here. I'm going to drop you off at another spot or whatever, right? Like you're running errands. You run errands during the day. You're going from someplace and you're going to someplace. So I'm not going to refresh this. This is, requires a Google Map API key. And if I go over here and do a quick Google search, go to google.com, use keys, map, Google Maps. Let me take off the underscore here. Free. Google Maps provides free tier for APIs to go to Google Cloud Console and create a new project and enable the JavaScript API and other desired APIs within the project to generate a new key. Okay, so that's what you have to do. You have to get your own. I can't share mine with you. Obviously, it's personal, it's confidential, but you can do a quick Google search and do this for yourself. And it's very enlightening and it's very empowering too. So you can go ahead and create your own key and your own, okay, billing account. Yeah. It's that account. So this is a process you would have to go through. API, IP address. Wait, address. Okay, restrict key, maybe later. Okay, so anyways, you would go through this little thing. You just do a Google search. It's pretty easy to get this set up. I can't share mine with you. It's personal and it's confidential. But you would sign up for your own. It's totally free, and you have a lot of access to a lot of data. It's not unrestricted and it's not unlimited, right? Like Google will charge you if you do tons and tons and tons of these searches, but that's fine. I think in this example, it's totally free. Doesn't cost anything for anybody, and you can get it for free too, right? If you run this as a business and you're doing this all day, every day, obviously Google is going to charge you. If you're a student or a teacher or just try and learn data science, nobody's going to charge you for anything, right? So you go ahead and get your own API key, you plug it in here, right? This API key goes here, Control F goes down here. And then you can go ahead and import all the data that you need to get the addresses right here, right? So this is important because you get longitude and latitude, and without the long coordinates, you really can't do like a lot of plotting or coordination or anything like that. Like you need the lats and you need the longs. Once you get that, you can do everything. Without that, you really can't do anything, okay? So once you get the lats and longs, and if it comes in the data, that's great. This data set that I had, this one that I showed you before, doesn't have the lats and longs, right? So I have to create that myself. I have to go to Google Cloud and get that myself. And there's a couple ways to do that. I think Google is the best, very accurate, totally free as long as you're not making tens of thousands of requests. So it's totally free. But there are other, and it's pretty fast too. There are other systems that are completely free, no matter how much you use it. But then they're slower and it's not quite as precise. So you have to make a decision between the trade-off. Do you want more precision and quick turnaround, and you pay for that, or you want totally free, right? And you sacrifice your time and your effort and your labor, right? So we got the lats and longs plugged in here. Okay, if I go over to the right, I have all the lats and longs and then the normalized volume. So this normalized volume basically is the volume of all the cars going through each intersection that I described before, the from and to place, right? You have those two because you have where you're starting and where you're ending. And we're taking the minimum, right, to get the volume and normalizing this condition right here. So again, the volume of cars minus data frame volume minus data frame minimum divided by data frame maximum minus data frame minimum. This is just normalizing the whole scenario of how many cars go through that intersection. So we want to normalize data just to get it more concise and more restricted and more efficient, right? That's how we can do the analysis here to get everything more efficient. You can just count the number of cars if you want. I think normalizing the volume of traffic is a little bit better for the algorithm and for the overall analysis. So we are going to also create a date and a weekday based on the date and the data frame. So we have the date right here, okay? So we can see 2012, 1/09, 2012, 1/10, 2012, 1/11, and so on and so forth. So I want to look at the weekday too. So I can tell Python, hey, go grab the weekday and tell me, is this Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday? Because it's going to affect the traffic patterns. Like you saw that originally, right? You saw that back at the beginning. We have traffic patterns here based on the day of the week, right? You can see like Saturdays and Sundays, it's slightly different. Like people are sleeping a little bit late. They're getting their tasks started a little bit late. They're running errands a little bit late on Saturday and Sunday, right? You can see it's not quite as dark. Monday, Tuesday, Wednesday, Thursday, Friday, it's pretty rigid. It's pretty strict, right? And you see that pattern repeat at the beginning of the rush hour and at the end of the rush hour, right? Saturdays and Sundays, kind of like a curveball, right? Like kind of goes a little bit different. It's a little bit similar, but kind of different because you don't have to go to work, right? You don't have those same rigid patterns that you have to adhere to for the normal 9-to-5 employee, right? So that is the weekend data. So I went ahead and used Folium to plot all the results of the map here, and you can see there's a lot of traffic downtown New York City. This is Lower Manhattan. This is just generalized. It's not like a specific road. It's not a specific street, and it just shows you generally the density, right? This is density-based traffic patterns around New York City. So you can see in Southern Manhattan, this is close to Wall Street. This is called, what is this? Not Battery Park, City Hall. This is City Hall, right? So the density of the concentration of traffic around City Hall is pretty intense because you have a couple feeders going through here, right? You have Williamsburg Bridge, you have Manhattan Bridge, and Brooklyn Bridge, and you have the Battery Tunnel, right? And a lot of these are funneling through the Holland Tunnel. So you have all these data points going through the Holland Tunnel and then branching out into New York City and into Queens and into Brooklyn too, right? So that's why you have like a concentration of traffic down here. So I created a map and I thought, okay, this is good. It's a good start, but it doesn't really tell me as much as I want to know. So I looked at another map, another way to create the map. So I'm looking at different type of heat map. And again, like it's pretty similar. The data is exactly the same, nothing's changing. You can see the patterns where the traffic is concentrated, right? So most of the people apparently come off of Brooklyn Bridge. And again, this is based on the counts of the cars that go through these intersections, right? So New York City has cameras everywhere, every square inch is covered, right? They can tell how many cars are going through New York City and either coming into the city or leaving the city, right? Like they know all those transactions, right? So this is good, but I'm thinking to myself, like, is this really helping me analyze traffic patterns? Well, yes and no. Okay, so I'm showing you a couple mistakes. Like I think this is kind of a mistake. It's not absolutely answering the question, but it's helping, right? It's progressive. It's helping that we're incrementally getting better and better. So let's try a different methodology here. Let me look at this map down here and see the concentrations of traffic. So again, if I go over here, whoops, I zoomed out a little bit too much. If I go over here, I can see the yellows are greater than 0.13 and greater than 0.15 is orange, and more intense than that, like greater than 0.15, 0.2, 0.20 or whatever, is red, right? So we can see the concentration of traffic. And again, it's mostly lower Manhattan, around City Hall, right? So we can see that definitively. Like this map projects something to me. It tells me, okay, wherever there's the yellow, there's some traffic, orange, more traffic, and red is the worst traffic, right? You can see it right around City Hall. It's the same place that we saw before, and we can get the volumes and counts. So 11241, so 11,241 vehicles went through this area, right, and captured on cameras and recorded on New York City cameras, right, at that point in time. But does that really, really, really help me understand the congestion of the traffic? So I tried a different map. I went and say, okay, I have the from and the to. If you look back here at the original data, you have the from and the to. All right, that's what we have right here. Or right here, anyways, like if I go back over here, you have the from place and the to place. So we can see the origin and the destination, and we can see the straight lines and all the maps and all the charting and all the plotting based on the counts of the cars going through that area, right? And we can see the volume, right? The volume is literally the number of cars. But if I zoom in here, is this helping? This is even worse than the other chart. Like this is just a straight line. We get the from and we get to. So it's very confusing. This, to me, is a little bit more helpful, but not super helpful. Over here, yeah, kind of helping out, but I mean, not really. I mean, there's some things to be desired, at least some opportunities to be desired. Is this map really helping me over here? This one, I mean, like, kind of, but not really. And this is, I'm not sure what that one is. Not refreshing. That's why I'm not refreshing. It's because it takes a while. Oh, shoot. Oh, I have to get that from the other thing. Okay, so I'll fix this up. I'll fix this up before I send it. So is this really helping the analysis? I mean, kind of yes, but kind of no. Like it's not really, really useful. So I said, let me try another way to do this. My Google. Let me try another way to do this and to get all the updates based on the streets and based on the logical coordinates of the whole system. Like how can I get all the streets and understand the traffic and understand like where are the congestion points or where's the traffic concentrated mostly, right? And how can I avoid that? So I take this route once in a while. I go visit some friends in New Jersey, and we go over here through the Lincoln Tunnel, sometimes go through the Holland Tunnel, depends where you're going, right? But you can see this is all red, right? This is where all the cars are going. This is the concentration of all the traffic over here, right? So that's what I want to try to avoid. So how do I actually plan my routine or plan my trips or my journey if I have to run some errands? Like how am I going to do the errand, and when is the traffic the least to help me, right? Because we have to answer the question, we're analyzing traffic patterns, right? But how do I use this information as knowledge and do a knowledge drop to you guys and help you to understand how to navigate around New York City, like based on the time of the day and the day of the week, right? So some things are off the table. I don't think I'm going to run an errand at 2 o'clock in the morning or 3 o'clock or 4 o'clock or 5 o'clock, right? So some things I'm just not going to do, right? Because yeah, I can go from point A to point B pretty quickly. But if it's 1 o'clock in the morning, I don't think I'm doing that. Like, I'm over 50 years old. I don't think I'm going to wake up at 1 o'clock in the morning and do that, right? So I want to look at specific times that realistically, like, I can run my errand. Like, how am I going to get to Costco quicker? How am I going to get to Whole Foods quicker? How am I going to get to what's the other place my wife likes to go? Costco, Whole Foods, Walmart. How am I going to get to Walmart quicker? I'm not going to go at 1 o'clock in the morning. Number one, maybe they're not even open. And number two, am I really driving at 1 o'clock in the morning to 3 a.m.? No. So I'm choosing specific hours that can coordinate with my schedule or can coincide with my schedule. We can have a confluence of times here that are appropriate for me. I'm not going to be driving around at midnight and 1 o'clock in the morning, right? So I'm taking valid hours and trying to make a validation assumption here. Like, when am I most likely going to Costco or Whole Foods or Walmart, right? Like, I'm not going at 1 o'clock in the morning, so that's off the table. So I'm going to go between 6 and 7, 7 to 8, 8 to 9, 8 to 9, so on and so forth, 7 to 8. By 8 o'clock, my day is done. I'm wrapping up. I'm going home, going to take a shower, put the TV on, and get ready to go to bed, right? So these are the valid hours where I can go run my errands. And this is when the traffic is the lightest, right? Like you saw over here, if I go back over here, you can see 1, 2, 3 o'clock, 4 o'clock, 5 o'clock in the morning. Yeah, that's the latest. And on the weekends, that's the latest. But I want to look at all of this simultaneously and say, like, what's the most realistic time that I can run my errands and the traffic is going to be the least. So that is how this analysis goes. So I took valid hours. Okay, I'm cutting out some of these weird hours, and I'm going to give you running around at 2 o'clock in the morning. I'm not going to do that, right? So we have valid hours and we have the weekday. So we're going to take all of this and combine it together, put it in the blender and mix it up and see what the outcome is. And based on the time of the day and the day of the week, the best time to run an errand in New York City is Sunday, 6 a.m. to 7 a.m. There's about 184 cars on the street in any one of these given intersections, right? You can see Saturday, 6 to 7, it increases a little bit. So we have the top 10. We have the top 10 best times, okay? So you can see the top 10 ends with Wednesday, 6 a.m. to 7 a.m. Actually, Sunday morning is the best. Wednesday, 6 to 7, the same hour, same time frame, is also in the top 10, but slightly worse, 451 cars in that intersection, on average 184. The worst times to go are Monday, 3 to 4 p.m. That is within the top 10 worst. The absolute worst is Wednesday afternoon, 5 to 6 p.m. 694 cars on average are in this intersection. Okay, so I would encourage you to do your own analysis. You can download the data from here. Again, you need your own Google API key. You can sign up for free. You can get that right here. This is the data set. You can do export to CSV format and then download. That's exactly how I got the data right there. Download, click the download button, and it goes to your download folder, or what is this thing called? Download folder. Okay. There's the traffic volume. So that's exactly what I'm analyzing, okay? So you can do the analysis for yourself. I would encourage you to do that. I think you're going to learn a ton. It's going to be very informative and enriching and very educationally intensive. So thanks for sticking with it to the end. I appreciate that. I really do. I really like it. So hopefully this helps you to understand traffic patterns around New York City, Python, just subject matter expertise around analysis, data management and data analytics, and also predictive analytics, and how can we use data to make our lives better. If I have to run an errand, I'm going to do it Sunday between 6 and 7. I'll set my alarm, get up a little bit early. 184 cars on the road at any given intersection around New York City. That's the best time to go. The worst time is Wednesday, 5 to 6 p.m. 694 cars at the intersection. So pretty much, I mean, give or take like 3 times the number of traffic. This is the worst time to go, right? And this is the best time to go. So we came up with a problem, we came up with a solution, and hopefully that helps you, helps you out a little bit. So I'm going to package up all this code and share it with you guys when I post the video a little bit later today. Thanks for your time again, and hopefully this was educational and informative, and I will see you guys in the next video. Goodbye for now.